The legacy concept of a woven, four-dimensional space-time fabric is a persistent mathematical illusion, not a physical reality. The origin of this artifact traces back to Hermann Minkowski and his foundational space-time interval equation. To mathematically merge space and time into a single continuum, Minkowski employed a specific abstraction. He converted time into an imaginary number, ICT. Multiplying time by an imaginary number forces the resulting equation to behave exactly like the Pythagorean theorem. This established a highly convenient geometric relationship between distance and duration. For over a century, the physics community treated this mathematical convenience as a literal physical geometry governing the universe. Modern relativity rests entirely on this imaginary abstraction. To evaluate the universe accurately, we must replace it with a strict mechanical framework. This diagram illustrates how reality evaluates strictly as a continuous Eulerian fluid, defined here as the tau metric. Under this framework, space is simply the static volumetric capacity of this fluid. Time is the localized rate of the fluid's kinematic advection. Every physical interaction within this space occurs strictly through volumetric fluid strain. The empirical constants of the Standard Model do not exist as independent forces. They emerge naturally as geometric projection ratios dictated by these fluid dynamics. When we strip away the abstract nouns and reduce the universe exclusively to fluid kinematics, the recurring linearity between squares found in legacy equations becomes a mathematical certainty. Albert Einstein defined the total energy of a particle with a relativistic equation. E squared equals the quantity pc squared plus the quantity m naught c squared squared. This animation deconstructs that equation by isolating a single spherical boundary within the continuous tau fluid. The kinetic momentum term maps directly to longitudinal advection, the fluid continuously flowing past the exterior of the boundary. Rest mass maps directly to transverse trapped rotation, the internal clock of the fluid circulating inside that boundary. These two vectors, longitudinal translation and transverse rotation, operate at exactly 90 degrees to one another. Adding these squared velocities together consistently yields the linear constant of the acoustic phase limit, which we measure as the speed of light squared. The Pythagorean theorem here is not an abstract geometry. It dictates the literal physical kinematic conservation of fluid advection. Mass and kinetic energy are not transmutable substances. They are exact orthogonal equivalencies of the same continuous fluid strain vector. At the subatomic scale, Max Born established that the probability of locating a particle is defined by the square of its wave amplitude. We have to ask why legacy quantum mechanics demands that physical reality is governed by a squared mathematical function. A fundamental particle evaluates mechanically as a topological defect propagating as a continuous acoustic wave through the tau metric. Continuous fluids do not interact in one-dimensional points. For two acoustic wavefronts to intersect, they must physically overlap across a surface area. As this diagram shows, squaring the one-dimensional amplitude is geometrically required to calculate that flat two-dimensional surface area. This exact physical cross-section dictates where the fluid waves structurally face-lock. What legacy physics mystifies as statistical probability evaluates natively as the literal physical area of topological acoustic intersection. This exact framework also resolves the fractional constants found in the Standard Model, specifically the 1/3 and 2/3 charges of quarks. This visual represents the tau fluid as a perfectly isotropic continuous space, meaning interactions disperse uniformly in all directions. Evaluating any three-dimensional vector field along a single one-dimensional axis mandates a strict mathematical projection factor of 1 over the square root of 3. Measuring the structural footprint of this fluid advection requires squaring the amplitude. Squaring that spatial projection yields exactly 1/3. This mathematical operation is the absolute geometric tax of the continuous fluid universe. You cannot project a three-dimensional fluid volume onto lower dimensions without paying this geometric penalty. This precise ratio correlates directly to thermodynamic degrees of freedom and the tensor projections of acoustic advection. Fractional charges are not discrete magical properties of subatomic particles. They are the unavoidable squared orthogonal projections of a three-dimensional isotropic metric. The standard model requires 11 dimensions and discrete virtual particles to bridge the fundamental forces. Continuum mechanics relies strictly on spatial volume and fluid strain. This diagram shows gravity operating strictly as the longitudinal advection of the tau fluid. Electromagnetism operates strictly as the transverse rotation of that exact same fluid. By definition, longitudinal bulk flow and transverse shear waves operate at exactly 90 degrees to one another. Because these kinematics are perfectly orthogonal, they naturally coexist within the same medium. They do not require string theory to reconcile. Gravity and electromagnetism evaluate as orthogonal equivalencies of the exact same macroscopic pressure metric. For over a century, the field of physics invented abstract particles to explain the structural behaviors of a continuous volume. The recurring linearity between squares in legacy physics equations evaluates as the absolute Pythagorean conservation law of reality. Advancing physical engineering now requires instruments calibrated to read fluid geometry, bypassing abstract assumptions of charge and mass. When we measure continuous volumetric strain, the entire ledger of physics collapses into a single cohesive geometry. Space, time, mass, and gravity resolve as the x, y, and z projections of fluid resistance. The imaginary framework of four-dimensional spacetime is obsolete, replaced by the uncompromising mechanics of the absolute continuum.